Hello, my name is Aaron Olah, and I am in Group B. My teammates Gary Vanderwater, John Roycroft, and I will be discussing the facts behind the 3 Mile Island event. 3 Mile Island is site of what is considered the worst nuclear power plant disaster in United States history. It occurred just south of Harrisburg, Pennsylvania on March 28, 1979. 3 Mile Island was, at the time of the incident, a 2-power plant nuclear generating station capable of producing over 1.7 net gigawatts of electrical power. This recent photograph shows the steaming number 1 plant in the foreground to the left and the decommissioned number 2 plant in the rear to the right. Plant construction began in 1968. 3 Mile Island, or TMI 1, came into service in 1974, and TMI 2, site of the incident, came into service in 1978. Both reactors were pressurized water reactors manufactured by Babcock and Wilcox. The TMI 2 reactor was a common commercial reactor design in that it protected against the release of radioactive fuel particles in a series of 4 containment barriers. The first lines of defense are the pellets where the fuel is actually contained and are housed inside the fuel rods. The next line of defense is the reactor vessel itself, followed finally by the containment structure. A basic diagram of the TMI-2 power plant is shown here. The aforementioned reactor containment building is shown in the center and houses plant equipment such as the reactor, pressurizer, and steam generator. To the left is an auxiliary building containing much of the plant's emergency water supply and contaminated water retention systems. The turbine building is to the right of the diagram, containing the plant's secondary steam, condensate, and feed systems and electrical distribution. The ultimate heat sink, one of the plant's 2 cooling towers, is on the right. The early morning hours of March 28th saw the TMI-2 plant operating at 97% of full power, while TMI-1 was shut down for refueling. The events that followed were a series of plant component failures, significantly compounded by insufficient instrumentation, a failure of operators to diagnose plant conditions, and subsequent improper operator action. The initiating event was a trip of the plant's main feed pumps, attributed to water from maintenance being performed on the plant's main condensate polishers. Without any makeup water coming into the steam generator, the plant's automatic protection system shut down the steam turbine supplying the plant's electric generator. With no major steam load and no incoming feed water, the temperature and pressure of the reactor coolant system began to rise. When the reactor coolant pressure rose to a predetermined set point of 2,255 pounds per square inch, the primary pressure relief valve designed to reduce that pressure opened, relieving reactor coolant and steam to a tank inside the containment room. Despite the fact that the primary pressure pilot operated relief valve opened, plant pressure continued to climb. 8 seconds after the first feed pump tripped, the reactor experienced a designed reactor scram. Although the reactor was no longer producing heat due to fission, decay heat was now present. Because of the plant's high power history, the decay heat level that needed to be relieved was equivalent to about 6% reactor power. After the main feed pump trip, another designed plant backup feature automatically energized. 3 emergency feed water pumps started and were noticed running by a plant operator. These pumps would have supplied the steam generators with water that was missing due to the failure of the main feed pumps. Neither that operator nor anybody else in the control room noticed the 2 isolation valve indicators in the emergency feed pump supply line that indicated shut. These isolation valves prevented any water from the emergency feed pumps from entering the steam generators. Up until this point, the power plant performed as designed. Even with the condensate polisher anomaly tripling the main feed pumps, the reactor was shut down and undamaged, and containment was intact. The real problem of the 3 Mile Island event happened as a result of what followed. Plant pressure eventually dropped when the reactor scrammed and the pilot-operated relief valve opened. The valve was designed to then shut 13 seconds after opening at a predetermined set point of 2,205 pounds. The valve instead remained open and continued to drain reactor coolant for another 2 hours and 22 minutes. The reason why the valve remained open for that amount of time was because the operators initially did not know it failed to shut. The indication for the status of the valve was based on the signal sent to the valve solenoid. When the solenoid de-energized, the valve open indication turned off, even though the valve remained fully open. The plant was suffering a loss of coolant accident without the operators knowing it. Pressure and temperature continued to drop dramatically, and so did the water in the pressurizer. To combat this, operators turned on a charging pump to raise pressurizer level, which dropped pressure and temperature even more. The water level rose as the pump was able to overcome the capacity of the stuck open primary relief valve. By about this time, the steam generators with their blocked emergency feed pump supply lines boiled dry. This caused the reactor coolant to heat up and expand and pressurizer level to rise even further. Primary pressure, on the other hand, dropped so much that the plant's emergency core cooling system, or emergency injection, automatically initiated as designed. The system began injecting about 1,000 gallons of water per minute into the primary system to maintain pressure and remove decay heat. Because the level in the pressurizer was so high, a condition operators are normally trained to prevent, they actually reduced emergency injection flow to a minimum. About 5 minutes into the incident, the plant reached saturation. In this condition, steam bubbles began to form on the reactor's coolant channels. The steam bubbles displaced the coolant in the reactor, sending the water level in the pressurizer even higher. From this indication, operators believed the reactor and its primary coolant system had plenty of water. The opposite was in fact the case, and the core was on its way to being uncovered. Throughout the next few hours, plant operators were oblivious to the warning signs that would have alerted them to the conditions in the core. Alarms were going off signaling high radioactive sump levels. Instrumentation was showing higher than normal neutron counts. Reactor coolant pumps were cavitating so bad with the steam forming in the core that they were actually shut off. By 6 a.m., 2 hours into the incident, damage inside the core was evident. It wasn't until the Babcock and Wilcox site representative inquired during a conference call as to the status of the primary relief valve drain line that the loss of coolant accident was stopped. Although the loss of coolant accident was over, the damage to the core continued. At the point in time where core coverage was estimated to be at its minimum, it is possible that 2/3 of the core was uncovered. Post-incident calculations show the temperature in the reactor reached between 3,500 and 4,000 degrees Fahrenheit. Radiation readings, which were low for the first 2 hours of the incident, increased drastically after 6 a.m. By noon, the auxiliary building had radiation levels up to 1,000 rem per hour. The accident at 3 Mile Island wasn't just a date in 1979. The event continued in the coming days and months and still has effects on the nuclear power industry today. In later parts of this project, you'll hear about the other stages of the incident, including effects on the environment, public response, and resultant regulations.